Good morning, everybody. Day 27, Math 133. We're going to talk about the Chapter 11 review. This is our last worksheet, our last project, our last thing before we do the sample final exam, which is still its own worksheet. So I guess it's not the last worksheet, but um, anyway, Chapter 11 review is on page 563 in your course pack, but this is the last of the material that we're going to learn. So once we are done with Chapter 11, you'll know everything I know about statistics. Well, that's not true, but everything that we're going to cover in this class. So you'll be statistics experts for beginner statistics. So, um, chapter 11 review worksheet is on page 563. Uh, you'll want to click on the link in Canvas because this is going to take you to the data sets for all of our different worksheets. And chapter 11, we have to scroll all the way to the bottom, but it's right here, chapter 11 review. There's a link for StatCrunch. When you click on that, that's going to bring you to this, which I will drop in the chat so you don't have to go find it. But if you're watching it on the video, if you're watching it um, on the recording, you'll have to do that. You'll have to click in Canvas and click that link and then scroll down and click the StatCrunch for Chapter 11 review. Speaking of which, if you are watching this on the video, uh, this is the last week that you'll have to do discussion boards. So if you are here in Zoom, you do not need to do week 14 discussion board. But if you miss the Zoom on Tuesday and on Thursday, you'll need to fill out the week 14 discussion board. There's no discussion board for next week because next week is the final. Okay. So you don't have to come to Zoom next week. Okay. Um, you do have to take the final. So speaking of taking the final, uh, don't forget that if you're taking it at the testing center, you need to bring in a an ID. You need a valid photo ID. Okay. So if you're taking it at the testing center, make sure, I mean, a driver's license will work, student ID will work. It's got to have your name and a picture on it, and you're good. Okay. Um, Otherwise, they will not let you take the test. Okay. So be aware of that. This chapter 11 review that we're going to cover today is due on this upcoming Thursday, but if you want to turn it in late, like always, I will accept it and mark 1 point off for each day that it is late. Up until May 1st, you have until 11:59 p.m. on May 1st. Anything turned in after that will not be accepted and graded. Okay. So even though usually I give you up to 3 weeks to turn in things late, well, next week is the last week, so this chapter 11 can only be uh, a week and a half late. Otherwise, it's toast. I don't know. It's yeah, a week and a day, whatever. Okay, so that's it for all of that. Um, we're going to be covering the sample final exam this upcoming Thursday, and then Elaine and Cindy are going to cover more of it on Monday, the 27th, and then I'm going to cover the last of it on the 28th. So we're going to get through the entire sample final exam together in class. But the sample final exam is one of the best ways to study for the test because it covers all the material that we've learned throughout the entire semester. So if you want to really study for the final exam, like I want to be as ready as possible, my recommendation is sit down with the sample final exam and try doing it yourself first because it's just like the final exam. Like if I can get through this, all of these questions from the sample and I don't have any problems, then I'll be ready to go for the final. If I come across something where I'm like, I'm not sure how to do that, then you'll know what to study. Okay. Um, so try doing it yourself and then bring your completed sample final exam to class on Thursday. And I will give you, here's how you do question one, here's how you do question two. I'll give you all the answers and then you can say, oh, I got that one wrong, and I know I need to study that. Okay. As opposed to if you just bring a blank one on Thursday, and I show you, okay, you do this, this, and this, a lot of times you're like, oh yeah, yeah, I can do that. I remember that. But if you don't actually try it yourself, did you actually remember how to do it right? Sometimes, when I show you something, you're like, I remember how to do that. Can you remember how to do it if it's a blank paper in front of you? Because that's what happens in the final. On the final exam, I'm not there to give you hints. There's no hints. It's, do you know how to do this or not? So anyway, that's not scaring you or anything. You guys are all fine. So okay. So it's up to you if you want to give the sample final exam a go or not. So on your own. That's that. Okay, so let's jump into our worksheet. So page 563, chapter 11. So chapter 11 is all about looking at multiple samples. Okay, we might take two different samples. Okay, and compare them. Sometimes those samples are from the same population. Okay, and sometimes they're from two different populations, and we're trying to see if those two different populations are significantly different. Okay. Um, Sometimes those samples are from the same population before and after something. Okay. But anyway, the point is we have two samples and we want to compare them, which means we'll have two p hats, we'll have two different x bars, right? Two different results. Okay. Okay, so there's a lot covered in chapter 11. You remember in chapter 9 we talked about single sample sizes as well as single confidence intervals. And then chapter 10 we talk about single hypothesis testing. Chapter 11, we're doing all three of those. We're doing double sample sizes, double confidence intervals, and double hypothesis testing. Okay. So it's important to pay attention to what you're trying to do as you're doing those things, okay? And also because of that, there's a lot of different pages in your sample, in your exam notes packet that cover chapter 11 stuff. So you've got your chapter 11 uh, flow chart, and you can bring that with you to the final exam, okay? So make sure you have that and you're familiar with it, okay? Because it's going to help you decide what different things I'm going to do, right? What am I going to click on in StatCrush? So for question number one, in 2024, 40% of adults in Michigan, 38% of adults in Wisconsin identified as Republican. You want to conduct a study to find if the difference in these percentages have changed. So it's 2 years later, we're coming up on the midterm elections. Have those numbers gone up or down? So how many adults in Michigan and how many in Wisconsin must you sample to correctly gauge the difference with a 95% confidence 3.0? Okay, so we need the formula, we need the substitution, and then what's our result? Okay. Now, what page? So I'm going to give you hints, but I'm going to ask you to give me the hints and then I'll write them down. What page do I need to look at to do this? What page in our exam notes packet? Because this thing is huge, right? There's 14 pages in this exam notes packet. So Montez says we go to page 263. So page 263 is hypothesis testing for a single mean. And I don't have a single one. I have two different populations. I'm going to take a sample from Michigan and a sample from Wisconsin. So Rachel says page 260. Page 260 is for a confidence interval for two populations. I am going to build a confidence interval, but not yet. First, I need to figure out how many I need to sample. Yep. So Elaine is saying that this is not asking you to build the confidence interval, and you can't because I don't have a p hat for either of my samples. These right here are from 2024. I want to see if it's changed. Rachel's got it. Page 261. Page 261 at the bottom. Okay. This is a question asking what sample size do I need to rerun this to rerun and recalculate a confidence interval. Okay. Um, so I'll be using one of these depending on if I have a prior estimate or no prior estimate. Okay. And as you saw just a second ago, we were like, wait, it's on page 263. No, it's on page. So we were jumping all over the place. So I had said like a while back, like write out on your 8.5 by 11 piece of paper what each page is, just in your own words. So page 261 is if we're calculating sample sizes for how many. Page 260, let's see, what else was there? Page 264 is hypothesis testing for two independent proportions. Page 265 is hypothesis testing for matched pairs, right? And we're going to look at all these, but it's helpful if you write on your 8.5 by 11 paper what each page is in your own words. So you don't have to flip through on test day trying to find the right page. Okay. And the flow chart will also help you with that. Okay. You look at this question and say, is it asking me to calculate a sample size, a how many, or is it asking me, so right here is the words how many, or is it asking me to actually build a confidence interval? Okay. All right. Anyway, that all said, let's do now, let's see, question number 2. How many again, right? How many adults must you sample to gauge the difference? Uh, oh, so this is a different question. Still asking about Michigan, Wisconsin, but it's a completely different topic. Now we're not talking about Republicans now. It's correctly gauge the difference in percentage of residents that believe in astrology. I mean, I guess you can try to argue whether Republicans believe in astrology or not. Anyway, we need the formula. We need the substitution, and we need the result. So this is still on page 261 at the bottom. Okay. All right. Let's do, all right, question number 4. Circle true or false for each statement. Explain why if it is false. Type 1 errors are always worse than type 2 errors. True or false? Rachel says false. All right, why? So does that mean that type 2 errors are always worse? Depends on the context. That's correct. It depends on the context, which, what does that mean? It means it depends on the real world circumstances. Sometimes type 1 errors are worse than type 2, and sometimes type 2 errors are worse. And sometimes they both suck. I've said that before. We haven't talked about an example, so I've got an example here. So we're gonna pause for just a second. I apologize, but I wanted to make sure I covered this. Um, so let's say, so at the Olympics, in order for an athlete to participate, they need to do a drug test to show that they have not been using steroids or performance-enhancing drugs, right? And that's true of all athletes. They test every athlete, and when they test them, um, they are doing a hypothesis test based on the steroid level in their blood. Okay, normal humans have natural steroids in them. Okay. So, it's not, I'm not testing that the steroid level equals 0. I'm just testing if it's a normal level or not. Okay. Um, and I can't be 100% confident in my test. In order to be 100% confident, I need to sample the entire population. I need to test the whole population. What is the population in this case? Well, in this case, if it's a blood test, I would need to extract all of your blood and test it. We're not draining anyone of all of their blood. Okay. So I'm taking a random sample and, taking a blood sample. Okay. But it is only part of your blood. And so I can't be 100% confident. Now I can be really confident. I can be 99 or 95 or, hopefully 99.99%, right? But my null hypothesis is that that athlete's steroid level is normal. Alternative hypothesis is that they've been using drugs and that their steroid level is above normal. Okay, so this is a one-tailed test. Now, reality would be that they have not been using any steroids, right? Any performance enhancing drugs. Okay, so this is for an athlete. They're not using steroids. If the null hypothesis is not true, then that would mean that they have been using. Okay. Now we again can't know what the reality is. We can be 99% confident, but we can't know it for sure. We still have to make a decision. If we do not reject the null, then that means that we believe that this person is fine. And so if that's the case, the decision that the Olympic Committee would make would be let the athlete race, right? Let them participate. If we believe that the null hypothesis is incorrect and we reject it, then when we reject the null hypothesis, we will not let that person race. Correct? Hopefully that makes sense. Now, we've said before, this is a correct decision. This is a correct decision. Over here is a type 2, and this is a type 1. Let me ask you guys, which of these errors is worse, type 1 or type 2? Which of these errors is worse? Well, what would these errors be? This one would be, uh, so Rachel says type 2. So let's start with that one. This is that the athlete is using steroids. This person has been using performance enhancing drugs. They're using steroids, but they get to race. Is that fair to the other participants? If they're using steroids and you let that person race, that's not good, right? That, you know, detracts from the integrity of the game. So, uh, anyone else want to say whether they think type 1 or type 2 is worse? Elaine, Elaine's, Elaine's saying depends. She's hemming and hawing. Caleb says 2, right? Because, you know, we don't want we don't want the game to be unfair. We don't want that if this person is taking steroids and they break a world record, like we don't want that to be because they were taking drugs, right? That makes it so that that record, isn't accurate. Okay, that person wins a gold medal. Like that's not fair, right? However, let's think about what happens with type 1. This person is not using steroids. They've never touched them in their life. They are not using steroids, but is not allowed to race. Well, that sounds fine, right? Because this person, they don't get to race. Well, it's not fine. So Elaine is saying, depends if you're the athlete. Think about it from this person's perspective. This athlete, I don't know who they are, but let's say, Jim, he's never used steroids in his life. And he's worked 4 years training every day, living like, he's not eating any pizza. He's living healthy and he's working toward being able to participate in these games. And he does this blood test and they say, "Oh, I'm sorry, your steroid levels are elevated. You cannot participate." Not only does that suck, but that's going to get out, right? Like people are going to find out that this person was not allowed to race because of steroids. So that's going to affect more than just them not getting to participate. Maybe they had like sponsorships. They're, you know, people are not going to they're not going to sponsor them anymore. they're gonna, lose, commercial deals or whatever. Um, like that's gonna ruin this person's life, right? So sometimes type 1 sucks, sometimes type 2 sucks, sometimes they both suck, and you need to be as accurate as possible. Okay. So anyway, um, I'll stop going off on tangents, but I wanted to at least give you an example because I've said that before in class. So a p-value of 0.5 is more statistically significant than a p-value of 0.10. True or false? True. Okay. All right. So if it's true, we don't have to explain why, right? All right, next page 564. Um, a new post-surgical treatment or common surgery is being compared with standard treatment. Okay. 7 patients received the new treatment, 7 patients received the standard treatment. Here are their recovery times, how many days it takes before they're, healed and they can leave the hospital, right? Um, find the following. So, and then after we do that, we're going to construct a 95% confidence interval of the difference in recovery times. So, uh, what page do I want to look at? Well, let's start with this one. So, I need to find the sample size for the standard procedure, the mean, standard deviation, same thing, mean standard deviation of the new treatment. Okay. Um, how would I find all of this? What page would I be looking at? So to fill out these, I need to get the mean and the standard deviation. What page should I look at in order to figure out how to calculate means and standard deviations? I mean, unless you already know how to do it, like the StatCrunch buttons off the top of your head, then you're good to go. To may know what buttons I click on in StatCrunch. I mean, you don't have to memorize them. That's the whole point of the exam notes packet is all the StatCrunch buttons are listed in here. It's just you got to find what page it is. Page 250. Well, my exam notes packet only goes up to page 253. That's okay. Page 260, yeah. So page 260. So page 260 is going to we will need for building the confidence interval for two proportions. Okay. Um, when you do this, it's going to do, you need proportion stats to sample with summary. It's going to ask you, what is your N, what is your X bar, what is your S? So you've jumped ahead a bit on me. Page 260, we will need it, but so over here, I've got stat, portion stats, two sample. So do I want two sample with summary or two sample with data? Oh, I have the data. Oh, so maybe we can do it. All right. Well, let's see then. Oh, wait, I hit the wrong thing. Oops. Not proportion stats. Sorry. Um, I need key stats, to sample with data. There we go. And we're doing a confidence interval at 95%, right? So, so I get my confidence interval, I got my critical t-value. This does not give me the mean and the standard deviation of my samples. So I want to fill this out. So yep, Rachel's got it. There we go. Um, to get the mean and the standard deviation, need I need page 254. And there's three methods on page 254. I need method one. That will give me my mean, standard deviation, and my sample size. Okay. Then, yes, when I want to construct my confidence interval down here, 95% confidence interval, yes, you are correct. I need page 260. Page 260 is a confidence interval. I'm not looking at proportions, so I have either matched pairs or independent means. Um, these ones are independent, so I need the very bottom of page 260. Okay. Um, okay. So where's that? Um, let's go to the next page, page 565. A simple random sample of US adults embarked on a program of regular aerobic exercise. Their heart rates and beats per minute were measured before and after with the results at the right. Verify the requirements are met. So you need to make sure it's random, independent. Now, since we have two different samples, you're not just checking that it's independent you need to check that they're independent or dependent of each other. Okay. In this case, um, I'm not checking independence, I'm checking dependence. And I need to check independent of the population. And I also need to check that it's normal. Um, so we're so let's see, what are we doing here? We're doing uh we've made a confidence interval, right? This is a paired T confidence interval. So that's on page 260 again. On page 260, we have confidence interval for two proportions. We also have the confidence interval for means, but there are two different ones. One is the confidence interval for means of matched pairs, and the other is confidence intervals for two independent means. Okay. So how do I know which one I'm doing here? So um, matched pairs is when I have the data is matching up. Okay. In other words, I have what's called we have dependent samples. Okay. We still have two samples, but now they are dependent. Versus down here, if I have two samples and they're independent. So how do you tell the difference? So independent would be where I have two samples measured once, two different groups measured once. In order for them to be independent, the two samples have to have no overlap. Okay. So an example of that would be M&Ms and Skittles. There's no candy that's both an M&M and a Skittle at the same time. Okay. You can have independence where they're from the same population. So if I wanted to look at uh, just M&Ms, I could have a sample of M&Ms and another sample of M&Ms as long as there's no candy that's in both. So if I have this bag and this bag, two separate bags, you can't have an M&M that is in both bags at the same time. Okay. Now that's obvious. What if I was looking at like a sample of adults in the US? Like I was trying to measure like average height of all the people in the US. If I wanted to look at two different samples, I could have this sample, but I need to make sure that when I pick my second sample that no one is in both samples at the same time. Okay? That's independent. Dependent means that the two samples are exactly the same. They do have overlap, but more than that, they overlap perfectly. So an example here would be what we're looking at in this case. Simple random sample of US adults embarked on a program of regular aerobic exercise. Their heart rates were measured before and after. So if Jim gets selected for this sample, we would measure his before heart rate. He's in the first sample, he's in the before sample, and he also is in the after sample. And it's not just Jim, it's every single person in the sample is in both the before and the after numbers. If we take Jim's heart rate before the exercise and then he leaves and doesn't do the exercise and we don't have a way to measure his after, then that means that this study's not going to work. Okay. So everyone has to be in both before and after. So this would be an example of one sample or one population, one group, we'll call it, measured twice. Okay. And that means that it's a matched pairs. Okay. All right. Anyway, this is all on page 260 in the middle. Okay. So there's all that. Let's go on to the next page. Page 566. In a randomized, double-blind clinical trial of a new vaccine, rats were randomly divided into two groups. Subjects in group 1 received a control vaccine. Subjects in group 2 received the new vaccine. So we have two different samples. Researchers found 19% control group experienced fever as a side effect. 25% experienced fever as a side effect. Okay. So, what page do we need to look at for this? We're doing hypothesis testing. And we have two different samples. Are we looking at means or proportions here? So we are looking at what percent of the rats experienced fever as a side effect. So percent would be a proportion. So we need a two sample proportion hypothesis test. That is on page 2 test for difference between two independent proportions, page 264. Okay. All right. That's the only hint for that page. That's the only question on that page, so it's fine. This worksheet is actually 6 pages, so we're going to keep going. A couple more hints. Page 567. A researcher for Consumer Reports believes that SUVs have worse gas mileage than sedans. They gather a random sample of both vehicles, measure the gas mileage, conduct a test. What type of test is it? Okay, so the hint I'm going to give is what page we want to look at for this. So I'm going to ask you guys. I'm doing a hypothesis test, and I have two different samples. I have a sample of SUVs and a sample of sedans. Page should I be looking at this for this? Well, that depends on whether they are independent or whether they're matched pairs. What do you guys think? Page should we be looking at? Take a look at your uh, flow charts. Do we know? Earlier I had lots of guesses and we were kind of flipping through trying to find it. And um, so just because your guess was wrong before doesn't mean that's a problem. Like, give me a guess. Like, what page should we be looking at for this hypothesis test? So we are testing uh, the average gas mileage, and we have two different samples. We have a sample of SUVs and sedans. So I want to know if they're independent or matched pairs. So matched pairs is where you have the same group measured twice. Well, that's not what we have here. We have a group of SUVs and a group of sedans. Those two are different. They are independent samples. Okay. You can't have a car that's both an SUV and a sedan at the same time. Okay. So I need, yep, Rachel's got it, page 265. This is the test for means. Oh, nope. Nope. That's matched pairs. I don't want matched pairs. I want independent. Test for the difference between two independent means. Page 266. Page 266 is uh, means, because I'm looking at average gas mileage, independent, and two of them. Okay. All right. 266. That is a 6 now. All right. Our last page is page 268, and then we'll go back through and we'll do all the stuff. A company studied two programs for compensating its sales staff. 9 random salespeople participated in the study. In program A, the salespeople were paid a higher salary. In program B, the same salespeople were paid a lower salary with a larger commission for the next 6 months. Following data are the amounts sold for each salesperson. Find the differences. So to find the differences, you just subtract these two. So 55 minus 53 is 2. 21 minus 24 is -3. So make sure you're paying attention to whether you get a positive or negative as you fill this out. Okay. Can you conclude that the mean sales differ between the two programs? Use a appropriate hypothesis test with a 0.5 level of significance. So what page should we be doing for this hypothesis test? So first of all, it's a hypothesis test, not a confidence interval. Second of all, are we looking at proportions or means? We're looking at the average amount of money that the salespeople sold. Um, okay, so that's mean. And we have two groups. We have program A and program B. So it's not page 263. Page 263 is hypothesis test for a single mean. I'm looking at two different ones. So am I looking at matched pairs or independent means? Matched pairs is page 265. Independent is page 266. So each person is in both program A and program B. So the first, so like maybe, so they wrote it as person one, right? This is salesperson one, salesperson two, right? Maybe we shouldn't write one, two. Maybe we'll write like his name. So here's Jim. Poor Jim. He got kicked out of the Olympics and now he's working as a salesperson. Anyway, um, so this person sold $55,000 on program A, and then 6 months later sold $53,000 on program B. So it's the same person measured twice. This would be matched pairs, page 265. All right. Hopefully that makes sense. Okay, so we're gonna stop here on the recording, and then we're gonna go back and fill in the rest.